Across the world, intelligent systems are beginning to perform tasks once considered uniquely human. Writing, research, design, programming, analysis. What started as an experimental technology is rapidly becoming part of everyday life. In offices, in classrooms, in laboratories, in factories. With every passing month, these systems become more capable, more accessible, more deeply integrated into modern life. For some, this represents extraordinary opportunity. For others, profound uncertainty. Because every technological revolution changes more than tools. It changes the skills societies reward, the institutions they build, the opportunities they create, and the futures they make possible. The question is no longer whether artificial intelligence will reshape the global economy. The question is how deeply. For the first time at global scale, machines are beginning to augment, and sometimes automate, parts of human cognition. And nowhere are the stakes higher than in a country preparing to bring millions of young people into the workforce over the coming decades. Because if intelligence itself becomes automated, what happens to the world's largest young population? India enters the age of artificial intelligence at a remarkable moment in its history. No country has a larger population preparing to participate in the future economy. Across the nation, millions of young people are moving through schools, universities, training centers, startups, and workplaces with a shared expectation that education will create opportunity, that skills will create mobility, and that economic growth will create a better future than the generation before them. For decades, that expectation was reinforced by India's rise as a global hub for knowledge work. Indian engineers helped build software used across continents. Indian technology firms became trusted partners to some of the world's largest corporations. Global businesses expanded technology, operations, and research teams across Indian cities. In many ways, India's growth story became closely tied to human intelligence at scale. Talent, education, engineering, problem-solving, the ability to transform knowledge into economic value. But artificial intelligence is beginning to challenge assumptions that shaped the modern workforce for decades. Research, documentation, customer support, software development. Many forms of cognitive work are already being accelerated by intelligent systems. This does not make human workers irrelevant, but it does change the nature of the work itself. And for a country expecting millions of young people to enter the workforce in the years ahead, the change carries enormous significance. Because India's demographic advantage is not guaranteed. A large young population can become an extraordinary engine of prosperity, but only if opportunity grows alongside aspiration, only if skills evolve alongside technology, only if institutions adapt as quickly as the world around them. The challenge facing India is therefore larger than employment alone. It is about productivity, capability, competitiveness, and the ability of an entire generation to participate meaningfully in an economy increasingly shaped by intelligent systems. The age of artificial intelligence is arriving whether societies are prepared or not. For India, the question is no longer whether AI will matter. The question is how successfully the country can adapt to it. Because AI is no longer optional for India, it is becoming structurally necessary. But focusing only on disruption can obscure something equally important. Because throughout history, transformative technologies have rarely produced only one outcome. They remove certain constraints and create entirely new possibilities. The printing press expanded access to knowledge. Electricity extended productive hours. The internet expanded access to information. Artificial intelligence may do something similar for human capability itself, not by replacing people entirely, but by amplifying what individuals can accomplish. Consider a young entrepreneur starting a business today. Many capabilities that once required specialized teams can increasingly be supported by intelligent systems. Research, content creation, design, analysis, customer communication, routine operations. The barriers to execution are beginning to fall. And when barriers fall, opportunity often expands. This matters because India's future will not be shaped only by large corporations. It will also be shaped by millions of individuals attempting to create value within their own communities. people whose potential has often been limited not by ambition, but by access. Artificial intelligence has the potential to change that equation, not by removing effort, but by increasing leverage. And nowhere could that leverage become more important than education. For decades, access to high-quality education has remained uneven. The best institutions, teachers, and learning environments have often been concentrated within specific cities and socioeconomic groups. For millions of students, opportunity has depended heavily on geography, language, income, and circumstance. India's educational inequality is not only a social problem, it is a civilization-scale productivity problem. Because when large numbers of people are unable to fully develop their capabilities, a society loses far more than individual opportunity. It loses human potential at scale. This is where artificial intelligence may become something far more significant than a productivity tool. It may become cognitive infrastructure. A student struggling with mathematics can receive personalized guidance. A learner in a rural community can access educational support previously unavailable. Language barriers can begin to shrink. Knowledge can become more accessible, and learning can become increasingly adaptive to individual needs. For the first time, it becomes possible to imagine educational assistance reaching populations at a scale that traditional systems have often struggled to achieve. Of course, artificial intelligence is not a substitute for teachers, or institutions, or human judgment. Technology alone cannot solve every structural problem, but it can become a powerful force multiplier. A tool that helps capable people become more capable, a system that expands access to knowledge, a mechanism for increasing productivity across society. And once intelligence begins functioning as educational infrastructure, economic infrastructure, and productivity infrastructure, a deeper question emerges: who builds the systems that billions of people will depend upon? Because the future of artificial intelligence is not only about applications, it is also about the infrastructure beneath them. Artificial intelligence often appears intangible. A prompt entered into a chat window, an image generated in seconds, a voice responding to a question, a model producing information almost instantly. From the perspective of the user, it can feel almost weightless. But that illusion hides something important, because every intelligent system ultimately depends on physical infrastructure, vast data centers, specialized chips, power grids, fiber optic networks, cooling systems, and an enormous amount of computation. Every AI-generated response travels through layers of infrastructure that most people never see. Infrastructure that consumes energy, requires capital, depends on supply chains, and increasingly influences geopolitical decisions. This is why the global race for artificial intelligence is not only a race for better models, it is also a race for compute, the ability to process and train increasingly powerful systems. And compute itself depends on one of the most strategically important technologies in the modern world: semiconductors. Tiny components that quietly power almost every aspect of contemporary life. Phones, vehicles, factories, telecommunications, medical equipment, financial systems, and now artificial intelligence. The world's most advanced AI systems require enormous numbers of specialized chips operating together at unprecedented scale, which means the future of intelligence is becoming increasingly connected to the future of semiconductor supply chains. But chips alone are not enough. They require data centers, and data centers require energy, lots of it. As artificial intelligence grows more capable, the infrastructure supporting it grows larger as well. More servers, more electricity, more cooling, more investment. What appears on a screen in seconds is supported by physical systems built over years. This is the hidden layer of the AI revolution, the layer beneath the applications, the layer beneath the interfaces, the layer beneath the headlines. Because artificial intelligence is becoming something much larger than a technology product, it is becoming infrastructure, the kind of infrastructure that economies, institutions, and governments may increasingly depend upon. And once intelligence becomes infrastructure, an entirely new question emerges: who controls the systems beneath it? Because nations are no longer competing only to use artificial intelligence. They are increasingly competing to secure the foundations on which it runs. If artificial intelligence is becoming infrastructure, then every nation faces a similar question. Will it simply consume intelligent systems built elsewhere? Or will it attempt to build capabilities of its own? For India, that question is beginning to shape an entire ecosystem. Much of the global conversation around AI focuses on a handful of companies building increasingly powerful frontier models. But India's challenge is different. It is not only trying to build intelligence, it is trying to build intelligence for the realities of a population-scale civilization. A country with hundreds of languages, vast economic diversity, and development challenges that cannot always be solved using systems designed for very different societies. This is why a growing number of Indian AI efforts are focused on localization. Models trained for Indian languages, voice-first systems, translation infrastructure, education tools, and AI systems designed for Indian-scale deployment. One of the clearest examples is Sarvam AI, part of a broader effort to build sovereign Indian foundation models capable of operating across Indian languages and use cases. The significance of these efforts is not simply technological, it is strategic, because intelligent systems increasingly shape how people access information, services, education, and digital infrastructure. And systems optimized primarily for Western markets may not automatically solve Indian-scale challenges. But models alone are not enough. Every AI system ultimately depends on compute, and compute is expensive, which is why one of the less visible parts of India's AI strategy involves expanding access to the infrastructure required to build intelligent systems. Through the India AI Mission and related initiatives, India is quietly increasing access to advanced GPU infrastructure for researchers, startups, students, and developers. The goal is not simply to create larger models. It is to reduce the barriers that prevent talent from participating in the AI economy. Because a country cannot build sovereign intelligence if access to compute remains concentrated in only a handful of institutions. The long-term significance extends beyond technology. It is about capability. Who gets to experiment? Who gets to build? Who gets to innovate? And whether the next generation of Indian researchers, entrepreneurs, and engineers can help shape intelligent systems rather than merely consume them. Because sovereignty in the age of artificial intelligence may depend not only on who builds the most powerful models, but on who creates the conditions that allow capability to emerge at scale. And increasingly, those capabilities are being built on top of another foundation India has spent years constructing: its digital public infrastructure. Long before artificial intelligence became a national priority, India was already building something unusual. Not a social media platform, not a technology company, but digital infrastructure at population scale. Over the past decade, systems such as Aadhaar, UPI, DigiLocker, and ONDC have helped create one of the world's largest digital public infrastructures. Hundreds of millions of people now interact with digital identity systems, digital payments, digital documents, and increasingly, digital commerce networks. The significance of these systems extends far beyond convenience. They form part of the foundation through which a modern society organizes economic activity: identity, transactions, records, access, trust. The invisible rails that allow large populations to participate in an increasingly digital economy. This is why India's AI story cannot be separated from India's stack, because artificial intelligence may become the intelligence layer above these digital foundations, helping citizens navigate services, helping businesses make decisions, helping institutions process information at unprecedented scale. In many ways, India has already spent years building the infrastructure through which intelligent systems may eventually operate. But digital infrastructure also changes the meaning of sovereignty. Throughout history, civilizations protected sovereignty through the systems they depended upon most: trade routes, agriculture, water systems, fortifications, military power. Control over critical infrastructure often determined resilience, prosperity, and independence. The digital age is creating a new version of that reality. Earlier civilizations protected sovereignty through forts, trade routes, agriculture, and military power. Modern digital civilizations increasingly protect sovereignty through data, computation, AI systems, and digital infrastructure. This is no longer an abstract geopolitical debate. It influences how economies function, how governments deliver services, how businesses operate, and how citizens interact with the institutions around them. As intelligence becomes embedded within digital systems, questions of control become increasingly important. Who owns the infrastructure? Who governs the data? Who builds the models? Who determines how these systems evolve? Because the future of sovereignty may depend not only on physical territory, but on the digital systems through which modern societies increasingly function. And beneath every layer of digital sovereignty lies another foundation, one that powers everything from smartphones and payment systems to data centers and artificial intelligence itself. Semiconductors. India's semiconductor story began with a simple realization. A country that wants technological sovereignty must eventually build capability in the industries that power the digital world. That realization helped drive the Semicon India program and the PLI scheme that accelerated investment into the sector. Today, the most visible symbol of that ambition is Dholera, Gujarat. Here, Tata Electronics is building India's first commercial semiconductor fabrication facility. In partnership with Taiwan's PSMC, the project is expected to manufacture chips across mature technology nodes, including 28 nanometers, a significant step in India's effort to enter one of the most complex industrial ecosystems ever created. But the story became even more significant with the announcement of a strategic partnership between Tata Electronics and ASML. ASML occupies a unique position in the semiconductor world. Its lithography systems sit at the heart of modern chip manufacturing, and that is where the geopolitical significance emerges. For years, semiconductors have been at the center of an intensifying technology rivalry between major powers. Access to advanced chip-making equipment has become increasingly strategic. At a moment when critical semiconductor technologies are becoming more contested, India is finding itself integrated into parts of the ecosystem that underpin global chip manufacturing. The significance of the Tata ASML partnership is not merely about equipment. It is about capability, the ability to participate in one of the world's most important industrial systems. And Dholera is only one piece of a larger effort. From Tata's packaging facility in Assam, to Micron's investment in Gujarat, to the HCL Foxconn venture in Uttar Pradesh, India is gradually assembling the foundations of a semiconductor ecosystem. This is where the 28 nanometer story becomes important. The world often focuses on the most advanced chips, the chips powering frontier AI systems, but much of the real economy runs on mature node semiconductors. The chips found inside vehicles, industrial equipment, telecom infrastructure, and countless everyday systems. A large share of global semiconductor demand still exists at 28 nanometers and above. And their importance is only increasing, because every advance in artificial intelligence ultimately increases demand for computation, and every increase in computation increases demand for semiconductors. The AI revolution may appear to be driven by software, but beneath every model, every data center, and every intelligent system lies a growing need for physical computing infrastructure. In the age of AI, chips are no longer just industrial products. They are becoming instruments of national capability, which means India's focus on mature node manufacturing is not a compromise. It is a practical entry point into one of the most strategically important industries of the 21st century. Because in the age of artificial intelligence, sovereignty eventually reaches the physical foundations beneath it. And few foundations are more important than the chip. For much of this story, artificial intelligence has appeared as a technological challenge. A race for models, for compute, for chips, for infrastructure. But beneath all of these developments lies a deeper question. What happens when intelligence itself becomes a strategic resource? Because this is not the first time humanity has entered a transformational age. History is filled with moments when new systems reshaped the way societies organize themselves. Agriculture, trade, industry, the internet. Each changed the distribution of capability, and each forced civilizations to adapt. But the age of artificial intelligence is unusual. Because unlike previous revolutions built primarily around energy, machines, or manufacturing, this one is increasingly centered on intelligence itself, on learning, knowledge, reasoning, and the ability to transform information into capability. That makes this moment particularly significant for India. For millennia, Indian civilization treated the pursuit, preservation, and transmission of knowledge as a civilizational responsibility. Knowledge moved across generations through teachers and students, through oral traditions and written traditions, through mathematics, philosophy, language, logic, and inquiry. Not because knowledge guaranteed power, but because knowledge itself was considered a form of civilizational wealth. Today, humanity is entering an age in which intelligence is becoming infrastructure. And that brings an ancient question into a profoundly modern context. How should knowledge be created? How should it be shared? And how should it be used? The greatest challenge of artificial intelligence may not be technological. It may be human. How societies educate, how they create opportunity, how they preserve trust, and how they ensure that technological capability expands human potential rather than narrowing it. Because the future will not be shaped only by the most powerful models or the most advanced chips. It will also be shaped by the civilizations that learn how to use these tools wisely. And that is why this story has never really been about artificial intelligence alone. It is about whether a civilization can enter a new age of intelligence while remaining connected to the values that allowed it to endure in the first place. The future is often discussed as though it arrives all at once. A breakthrough, a discovery, a single moment that changes everything. But history rarely works that way. The most important transformations unfold gradually, through decisions made over years, through institutions that adapt, through investments whose significance becomes visible only much later. The age of artificial intelligence will be no different. India's future will not be determined by a single model, or a single company, or a single government program. It will be shaped by millions of decisions made across classrooms, universities, laboratories, startups, businesses, and institutions. The real question is not whether artificial intelligence will change India. It will. The real question is whether India can translate this new age of intelligence into broad-based capability. Capability that creates opportunity. Capability that expands productivity. Capability that allows more people to participate in the future rather than being left behind by it. Because every civilization eventually encounters moments that redefine the conditions under which it must compete, create, and prosper. This may be one of those moments, not because artificial intelligence guarantees success, it doesn't, and not because history guarantees failure, it doesn't, but because the decisions made during periods of transition often shape the decades that follow. The story of artificial intelligence in India is therefore still being written. In research labs, in classrooms, in factories, in data centers, in public institutions, and in the aspirations of millions of people preparing for a future that has not yet arrived. The age of artificial intelligence is coming. The question is whether India can once again transform knowledge into civilizational capability. If this documentary expanded how you think about civilization and the future, like, share, and subscribe to GyaanGatha for deeper explorations into humanity's next great transition.